am the STEM coordinator for the district. I am in charge of coordinating any community events for STEM. I'm also in charge of keeping data of the students that come in through the STEM program on the 3 pathways: computer programming, healthcare therapeutics, and STEM engineering. So we started off in 2016. We started off with the T-STEM Academy through TEA, and we started off immediately with the healthcare therapeutic program, and we also started with the STEM engineering. So the STEM engineering is the pathway that I am the one that teaches those courses, and that is mostly for aerospace engineering. We use the curriculum system scope, where students in their junior and senior year, which is their 3rd year and 4th year of engineering, actually get to design, build, and launch 2 different rockets. So in their junior class, their 3rd year, they get to design a Slakowski rocket, which has a goal to reach a 1 mile in altitude, and it has a 1-pound payload. The senior, once they are successful in the launch of that rocket, then their senior rocket is to design mathematically first a Oberth rocket. The Oberth rocket has to reach the speed of sound, which is considered also a transonic rocket. It does not have a payload, and once their mathematical calculations or design are approved through a NASA engineer, then they are able to build and launch that rocket.
5, 4, 3, 2, 1, ignition.
The NASA trip that we took is based on the curriculum, right? So we have built up to this point. We had made sure that these students have the skills, the knowledge, and the expertise of launching a hybrid rocket. And now they're taking that hybrid rocket that they launched their junior year or 3rd year and modifying it to become a transonic rocket, right? So now we're going from a goal of an altitude of 1 mile to reaching a speed of 343 meters per second. The point of going to this NASA trip is for the students to take what they're learning in the classroom and relate it to the real world, right? Right now, the push in the workforce is aerospace science. Students taking what they've learned in class and putting the knowledge in physics class their junior year, the knowledge that they have in engineering, and creating or calculating the math to say this rocket at this mass with this type of motor will reach a speed of sound is absolutely culminating to the end, right? It's the big finale. So if they can actually take those calculations, present it to a NASA engineer, and the NASA engineer says, your numbers look good, you're not surpassing the safety height limit, you're not surpassing the mass limit, and you are actually reaching the speed of sound, which is Mach 1, then I mean that shows that these kids, these students, have reached the potential of their knowledge and actually putting that knowledge into the real world scenario. I have a lot of students that come into, or I invite them, you know, during our STEM camps or anything like that, and I say, hey, come on in, you know, it's free. And they say, no, I'm not smart enough, okay? It's not about how smart you are, it's about you having the mentality that I'm gonna come in here to learn new skills. And that's anywhere you go, whether you're taking a new class, whether you're going to a different school, whether you're starting a new job, but it's how willing are you to learn a new skill. So always remember that.